Section 5.3, our objective today is I can apply theorems about parallel lines and segments that join midpoints of two sides of a triangle. All right, we're going to start out with our theorems today. So the first theorem says if two lines are parallel, so that's our given. We have two lines that are parallel. Then all points on one line are equidistant from the other line. Okay, so basically it's just saying that we have this line and this line, and we know that those are parallel to each other. And it's just saying that the distance from this point to this point, whatever that distance is, has to be the same as the distance from this point to this point. Okay, so in other words, these segments have to be congruent. Okay, so that's all it's saying. All right, then our second theorem. If three parallel lines cut off congruent segments on one transversal, then they cut off congruent segments on every transversal. Okay, so here's what it's saying. We have three lines that are parallel to each other. So these are all parallel to each other. And we have one transversal. Notice that this intersects at 3 points, A, B, and C. And so if we know that AB is congruent to BC, if that is true, then any transversal that we put on or put through the three lines, then that means that those segments have to be congruent to each other. Okay? But notice that we cannot not go across from one transversal to another. It just says on that particular transversal, the segments have to be congruent to each other. Okay? So if I had another transversal that, say, went through like this, then again, GH would have to be congruent to HI. Okay? So that's true for, as long as we know that's true for one transversal, then we know that we have congruent segments on all transversals. All right. Then our third theorem says a line that contains the midpoint of one side of a triangle and is parallel to the other side passes through the midpoint of the third side. Okay, so here's what's happening. We have some triangle A, B, C. And let's say point M is the midpoint of AB. And I have some segment going through M, but I know that this is parallel to this. Then if this is a midpoint and I know that this is parallel to the second side, then I know where the segment goes through on the third side, which is this one, this point right here. We'll call it point N. Then we know that has to be the midpoint of the third side. So we know then that this has to be congruent to this. That's what the theorem says. Okay. And then the final theorem for today says a segment that joins the midpoints of two sides of a triangle is, number one, is parallel to the third side, and number two is half as long as the third side. Okay, so here's what it's saying. We have some triangle, and we have some segment MN. And I know that M is the midpoint of this side, so I know that AM is congruent to MB, and I know that AN is congruent to NC. Okay, so this theorem says then that I know that MN is parallel to BC. I know that. In addition, I know that it is half as long as the third side. So in other words, if I know that this side is 6, has a length of 6, then I know that this has a length of 3. Okay? Or let's say that I know that this has a length of 12, then that means that BC must be twice that, or 24. Okay? All right, so let's look at an example where we have to apply this. So we have this triangle A, B, C. Have X, Y, and Z.
Mr. Jones, if you're still on campus, please dial extension 3111. Mr. Jones, if you're still on campus, please dial 3111. Thank you.
All right, so we're given that points X, Y, and Z are midpoints of segment AB, segment BC, and segment AC, respectively. Okay, so we know that these are midpoints. Okay? So then, if I know length of AC is 24, then XY has to be half of 24 because these are midpoints. So this has to be half of the opposite side, so that's 12. Okay? So if AB equals K, right? So this equals K. Then this has to be half of K. So therefore, YZ has to be K over 2. Okay? And if XZ equals 2x plus 3, then BC has to equal what? Okay? So XZ is this one. And so BC is this one. Okay? So BC has to be twice XZ. So then 2 times 2x plus 3 gives us 4x plus 6. Okay? Then if the perimeter of triangle XYZ equals 24. Okay, so all the way around this one, if I add those all up, it equals 24. Then the perimeter of triangle ABC, ABC has to be what? Well, each of the sides opposite are twice as long. So that means the perimeter has to be twice as much. So it has to be 48. Okay. All right, and let's look at this. So I have this line, this line, this line, and this line. They're all parallel to each other. And I have this transversal A, B, C, D, where I know all these segments are congruent. Then I have this transversal P, Q, R, and S. Okay? So my given is that the 4 lines are parallel, and on transversal AD, the parallel lines cut off congruent segments. Okay? So if QR equals 3x and RS equals x plus 12, what is x? Well, QR is this, and RS is this. And we know that if lines cut off congruent segments on one transversal, they cut off congruent segments on all transversals. So that means that the length of QR equals the length of RS. So therefore 3x has to equal x plus 12. So subtract x from both sides, we get 2x equals 12, so x equals 6. So in that case, x would equal 6. Okay? What if PQ equals 3x minus 9 and QR equals 2x minus 2? What is x? Okay, well, let's look. PQ is this one, and QR is this one, so they have to be equal to each other. So 3x minus 9 has to equal 2x minus 2. Subtract 2x, add 9, so we get x equals 7. Okay? What if QR equals 20? So QR, right here, equals 20. Then what does QS have to be? What is the length of QS? Well, RS also has to be 20, so QS has to be 40. Okay? So if PQ equals 6, then what is PR? Okay, so if PQ equals 6, so that's this. And PR is this, so that's double. So we have to multiply 6 by 2, so we would get 12. And how about PS? Well, PS is 3 of those segments. So if we multiply 6 by 3, we get 18.